Hello and welcome to the first 5 for 5th, 5 minutes for 5th grade everyday math. Thanks for all your feedback regarding the upcoming geometry unit. Our goal for these videos is to provide some insight on each lesson's goals in the most efficient way possible. And as with every EDM lesson, let's begin by taking a look at the math message. In lesson 3.3's math message, we are asking the children to prove that the measure of each angle of a square is 90 degrees. And here they will be applying what they know to what they don't know. But prior to presenting this math message, let's take some time ourselves to unveil the underlying meaning of this task. First, we need to recall that a circle can be drawn around any given point. So when you take a look at the polygons on this particular worksheet, we're going to select a point of intersection, draw a point there, and again a circle can be drawn around any given point. That's becoming now the center of our circle. So we have just created a circle, and we must stress circle is 360 degrees. So with the circle we just drew, we now have 1, 2, 3 angles in that circle. So that's the sum of those 3 angles must be 360 degrees. Let's take a look at another point. Circle can be drawn around any given point. Taking a close look at this, we now have only 2 angles in this particular circle. So the sum of those 2 angles must be 360 degrees. I want to really stress here that this particular angle is what we call a reflex angle, and that new vocabulary word will be coming up in section 3.4. So again, for the children, those 2 angles sum must be 360 degrees. So one more time, let's just pick a third point. Select my point, draw a circle around that point, and again I have 3 angles whose sum must be 360 degrees. Now let's go back to the math message. The question really is, how do we think the children are going to explain how to prove that the measure of each angle of a square is 90 degrees? What we do know is that we need to be prepared to guide them through their discovery. For instance, some children may just simply draw some lines and say, here's a square. So the angle has to be 90 degrees. Some may simply state that they just know that a right angle is 90 degrees. We all know that that's not a proof, but that is in their mind what a proof is. So we're going to pull out manipulatives, which is an excellent way of helping them through this proof. Here we show that by putting the squares down around the given point, again, a circle can be drawn around any given point. We now have 4 angles that are sharing that given point, again represented by the 4 squares. So 360 divided by 4 is 90. Let's take that now and look at some triangles, equilateral triangles, which we know equal sides and equal angles. If we take those triangles, place those around the given point, and again we'll just keep stressing, we have a circle can be drawn around any given point. We have now broken that circle up into 6 equal angles. So we ask the children, 360 divided by these 6 equal angles is proof that these angles are 60 degrees. It's an equilateral triangle, so every angle of an equilateral triangle is 60 degrees. And if time allows, I really recommend taking out some smaller equilateral triangles, and it would be a good idea to ask the kids, how many triangles do you think it's going to take to surround this center point? They may say 12 because they're significantly smaller than the blue ones. But again, it's worth picking their brain a little bit. So we take these red triangles, again stressing they are equilateral, and then they're going to should hopefully have an aha moment that it only takes 6 red triangles to completely surround that center point. So again, 360 divided by the 6 angles, every angle is 60 degrees. It's equilateral, so every angle of an equilateral triangle is 60 degrees. I would really recommend placing the smaller triangle on top of the larger triangle, because really we're going to stress that it is not the actual area of the triangle we're looking at, it's simply the angles, and by laying them on top of each other they can see that the angles are exactly the same. That little visual representation is helpful. Okay, now moving on to the journal page for this section. The reason we added triangles into that math message is because this particular journal page is geared all around triangles. And the children are going to take a pattern block, place it in that triangle, and we say the measure of angle A is, well, they just did this in the math message, so we're going to come back with 60 degrees. You're going to take the pattern blocks, well, the children are going to take them. They're going to be, the book recommends pairs. The children work in partner pairs, and they're going to take 3 triangles per pair to do this activity. If you have 6 triangles, that would be ideal. But what they're doing is they're simply placing the triangles inside the polygon that's given, and they're going to be answering the questions that the journal pages ask. In this particular one, angle B is it B? Angle B is comprised of 2 triangles being placed together, so hope the 60 plus 60 is going to give us 120 degrees there. And they'll proceed with this worksheet. Finally, we're going to end with the study link for that day. When you look at problem 3, the measure of angle H, I recommend putting that in for the students, putting in 135 degrees. I don't believe their background's going to allow them to be able to come up with that themselves. So provide them with that. And then with problem 4, you look at the measure of angle K. Again, it's requiring background knowledge of knowing that the base angles of an isosceles triangle are congruent. Again, I don't think we are there at this point. So wait those out. Thank you so much for your time, and see you at the